This is ELEC120 problem sheet 1, question 2, part C. So this question looks quite scary to begin with, but then if you think about it, it's actually just a variation of something we've done in our lecture notes. So we've got the situation where we've got three forces in a triangular arrangement. So three forces, three charges in a triangular arrangement, point A, point B and point C. And we've got positive charge at A, positive charge at B and a negative charge at C. We are told, sorry, not told, but they are equal because you're not given, just Q is a constant, so you can see they're going to be the same magnitude, they've just got different signs. So you're asked to find the resultant force Fr on the charge at position C due to those at A and B, and then show the direction of Fr on a sketch on your answer. And this is 5 marks from a previous exam question. So the first thing to do here is to actually just apply your common sense. So you've got positive charge here and a positive charge here. These are going to be pushing each other away. However, this is a negative charge, so this is going to be drawn towards them. But since these are of equal magnitudes, what it's going to do is it's just going to be pulled in a straight line towards the centre of those two charges. So that's the direction of the resultant charge. If you can get your head around that, you're pretty much there. So what I'd recommend is just have a recap of these slides from the lecture notes. So this is the situation. This is slightly different where they were all positive charges, but the mathematics is essentially the same. So what we've got is I've drawn a sketch here, and I've included the angle of 60 degrees because it's an equilateral triangle, and I've included the direction of Fr because we worked that out by common sense and we knew it was going to be pulled towards the centre of those two, and we know because it's going to be pulled towards the centre that's an angle of 30 degrees. So we can say that the force is going to be at 30 degrees to line BC. That's the direction. Now just for the magnitude, the total force is √3 times q squared over 4 pi epsilon naught L squared. That's just the equation that's taken from the lecture notes. So that's essentially how you do it. It looks quite complicated. Like I say, if you just get your head around what's going on, reread these notes. This shows how it's calculated. It's a vector sum, so it's two charges acting on a third. That's where that equation comes from, and that's worth 5 marks. So it's actually, the answer is very short, but you get a lot of marks for it because it's much more of a comprehension question. It's actually a lot more difficult than just putting numbers into an equation that you've memorized. So well done if you got that.